Which one of the following is not a vector space? Be careful, it was asked here, not a vector space. Please look at the option C. It is given here C over Z. It is not a vector space because Z is not a field. According to the definition of vector space, ये जो ओवर वाली सेट है द सेकंड वन, इसको एक फील्ड होना चाहिए. हियर जेड फील्ड नहीं है, सो सी ओवर जेड इज नॉट ए वेक्टर स्पेस. नाउ यू गॉट योर आंसर. Your need was to know which one is not a vector space. So C over Z is not a vector space. I shall teach you more so that you can find the answer of any question that will be asked under this category. You can find the answer of such a question either by definition or by tricks. But it is best to use tricks if in any entrance exam where tricks are available. We know that n, the set of natural numbers, w, the set of whole numbers, z, the set of integers are not fields, q, the set of rational numbers, r, the set of real numbers, c, the set of complex numbers are fields. Let us see two beautiful results. Any field forms a vector space over itself. For example, q over q is a vector space. Q is a field. The next result, any field is a vector space over the subfield. For example, R over Q. Q is a subfield of the field R. Let us come to the tricks. पहला set V, the set of vectors. दूसरा set F, the set of scalars. What are the tricks? दो बात याद रखिए. दूसरा वाला सेट जो है द सेकेंड वन, ये दूसरा वाला सेट जो है इसको एक फील्ड होना चाहिए. द सेकेंड सेट, दूसरा वाला सेट, और ये ओवर वाली सेट मस्ट बी ए फील्ड. देन सेकेंड सेट बड़ा नहीं होना चाहिए फर्स्ट सेट से. द सेकेंड सेट मस्ट नॉट बी ग्रेटर देन द फर्स्ट सेट. The second set must not be greater than the first set. Let us see along with examples. You can see Q over Z. Q over Z is not a vector space because Z is not a field. You can see R over C is not a vector space. Although C is a field, C is greater than R, so that R over C is not a vector space. Similarly, you can check all these. Look the green highlighted ones are vector spaces, and the red highlighted ones are not vector spaces. Okay. You could learn to get the answers of this kind of questions by tricks. How can you know the answers of this kind of questions? By going through the definition of vector space. Let us see the definition. It is your duty to go through the definition, to go through the whole definition. Please see the sixth number property. Alpha x belongs to V. Alpha belongs to F, alpha is any scalar, and X belongs to V. Let us speak of any one from our table. Let it be R over C. Here R is the set of vectors and C is the set of scalars. Please think about any element of C. let us take 2 plus 3i. You can take any complex number. You can take any complex number. Here you will take any complex number whose imaginary part is non-zero. If the imaginary part of a complex number is 0, then we can also set a complex number. It is also a real number. So that a real number, so that a real number is a complex number. So that a real number is also a complex number whose imaginary part is 0. Such a number is unsuitable to take in this case. Here it will be suitable. Here it will be suitable to take any complex number whose imaginary part is non-zero. We took so we took 2 plus 3i. This is alpha. 2 plus 3i. This is alpha. Let us take any real number. Let it be 4. This is x. So multiply alpha x. 2 plus 3i into 4 is equal to 8 plus 12y. 8 plus 12y. This is a complex number. And you can see the imaginary part of this complex number is not 0. The imaginary part of this complex number is 12. 8 plus 12y doesn't belong to the set of real numbers. Therefore, R over C is not a vector space. Similarly, you can check the others from the table.